Hello everyone. In this video, I will explain single-dimension arrays by taking you step by step through a method that decreases the value of color in a picture by half. I will demonstrate this along with how an array and variables are stored in memory by drawing a memory map of this method. Here, I have the code for halfColor in an image above, for which there are no parameters. We read code top to bottom, so starting at the top, we have a string called filename. When a variable is declared, space in the computer is reserved to represent that variable's value, and the name is used to find the address of that reserved space. So by setting it in reference to filechooser.pickAFile, we are picking a file and setting the address of that file to file name, like this. We can make our address picture file anything, but for this example, I will make it a flower. We then create a new picture object called picked and assign the file to it, essentially making our picked the flower. I then created a method called halfColor. Here in the body of the method is where we get the array of pixels in the picture file. Conceptually, you can think of a one-dimensional array as a row, where elements are stored one after another. To declare a variable that refers to an array, use the type followed by open and closed square brackets and then the variable name. So this portion right here. Pixel, open bracket, closed bracket, pixel array is the one-dimensional collection of variables of the same type. It may be better if we visualize it like this. The simple type pixel array is referring to the complex series of pixels 0 through however many there are in that image. It is essentially all of the picture's pixels laid out in one dimensions, of which each pixel contains its own information. By setting the array of pixels in reference to picked.getPixel, we set the array to the exact number of pixels that the picked file contains. So for this example, I will only show you a few of the pixels in the pixel array because there can be hundreds of thousands depending on the pixel dimensions of that image. We then declare a pixel to blank space to be used later. This essentially becoming null. If the object variable is declared but not assigned to an object, the reference is set to null, which means that it doesn't refer to any object, as I just explained. We then declare a variable value of type integer and initialize it with the value 0. We do the same thing for variable index, as seen in these two codes here in the body of the method. For this method, I chose to use a while loop, but a for loop could work just as easily. I prefer while loops so I can better visualize the steps that the loop takes. In the parentheses of the while loop is a description of the array of pixels that the loop will be executed to. So since index is 0 right now, the loop will begin at 0 up until the length of the whole pixel array. In the loop, the first thing we do is get the red component as described here. We then set the red component equal to the value times 0.5, making the new red component the first pixel of the first pixel half its original. So we have 60 is the new value, and then half of that becomes the new red component in set red, essentially becoming, here I'll write it here, 30. We then get the green component here, which is 100, and set it equal to value. And then set the green component equal to half that of the value, or 0.5 times value, becoming 50. Do the same for the blue, get the blue component, set it equal to value, and then set blue equal to, set the pixel equal to the blue times the value, half the value. So that becomes 45. After that, we tell the index to go to the next pixel with index plus plus here. That is, the index is now 1. 0 plus 1 is 1. Because 1 is less than the length of the pixel array as described in the body of the while loop, The while loop will continue from the start through the body of the loop until the loop will read false. And we can continue this by moving on to index 1 and continuing with the body of the loop, which is to get red, set that equal to value, which would become 70, and then the red component of that pixel becomes half that of the value, which is 35. And we will continue this process for every single pixel in the pixel array. The purpose of this code was to darken the color components of an image, which can be used for anything. This sort of thing reminds me of Photoshop editing when you want to lighten or darken a portion of the image or the whole image to create like a shaded or night effect. But arrays can be used for many different applications in daily life. For example, 2D arrays remind me of matrices. But it can also be used for image processing as well. Also, you can better understand 1D arrays by thinking of text on a screen, like public static void. The very string that you see in texts and words are an array of characters. I hope that explains arrays clearly, along with how to write memory models, for loops, and pixel arrays. I would appreciate any feedback you have. Thank you for watching.